Every element wants to be like the noble gases. How, though?
They have to have the max full. Yeah.
By having a full valence shell just like the noble gases. So how do we get electron configurations just like the noble gases with our atoms?
Either take off or put on.
We add or subtract electrons, right? So if we add or subtract electrons to have full valence shells like a noble gases, that's how we create ions. Well, if we look at some of your examples of transition metals, we start filling up that D section. We're not going to add or subtract a large amount of electrons in order to be like our noble gases. So take silver, for instance. Silver has an electron configuration of, krypton in brackets, 5s1, 4d10. Silver has a single oxidation state, or it'll form a single ion of +1. Ag +1. Now, how am I getting to Ag +1? How am I getting to an electron configuration like the noble gas of krypton? So here, I have neutral silver. I know silver likes to form oxidation states of +1 only. So in order to have a +1 oxidation state and to be like krypton, I'm going to take away this one electron from the 5s. This would create 5s0, 4d10. Krypton, though, does not have this 4d10. The 4d10 is not 10 electrons that krypton actually owns. So I don't have the exact same electron configuration of krypton, but I have a full 4d, so I'm actually quite happy, or silver's quite happy with a full 4d and just taking away one electron from the 5s. So we have general trends across the main group elements as far as how many electrons are taken in or given off based on whether you're in group 1, group 2, group 3, 4, 5, 6, or 7. But the transition metals, we look at stability and we look at how many electrons exist within that S. So take zinc, for example. Zinc also has a single oxidation state of Zn +2. Where am I taking those 2 electrons from to get the +2? So in order to be like argon, I have 4s, spin up, spin down. I have 3d, 1, 2, 3, 4, 5, and my 3d is completely filled. So, in order to be like argon, I will be taking away electrons from the 4s. And although I won't have the exact configuration of argon, I have something similar to it alongside also having a full 3d. So I take away these 2 electrons, and now I have zinc +2. So zinc won't lose all 10 of the 3d electrons plus 2 more in the 4s to form a, what, +12? Instead, it just has something that looks like the noble gas electron configuration of argon, but really it's a false noble gas configuration because I still have a full 3d.